Then we are going to see about the bases. So what is meant by a base? A base is just opposite to that of the acid. So it is bitter in taste. It's a soapy feel to touch. So a base is a substance. Usually it's the oxide or the hydroxide of the metal. So for example, Na, if you're taking the Na, so it will be either Na2O or the NaOH. So which can react with the acid to produce the salt and the water. For example, Na2O, sodium oxide, calcium oxide, it's a CaO, and cupric oxide is CuO, and iron oxides, FeO and Fe2O3, sodium hydroxide, NaOH, calcium hydroxide, COH twice, or all bases. Certain substances are also called the bases, but it will not fit into the above definition. The one of the very good example is the ammonia. It's a weak base. So it does not contain any OH minus ions, and also it does not contain any metal. It's made up of only the non-metal NH3, nitrogen and the hydrogen. But it forms a salt with acid without giving the water. So it should not be treated as a base, but ammonium hydroxide, the aqueous solution of the NH3. So it reacts with the acid to give the salt and the water. So NH4OH. So the NH4OH is nothing but the ammonium hydroxide, which can able to react with the HCl. So this OH minus is taken by the hydrogen, so it forms the H2O and plus NH4Cl, ammonium chloride. Okay. So now again we are uh, splitting the bases. So in that one, the bases, all bases are not soluble. Some of them are soluble, some of them are insoluble. If it's soluble, we call it as a alkalis. Okay. So for example, sodium hydroxide, potassium hydroxide, calcium hydroxide, so which are easily soluble in the water. So those are all we call it as a alkalis. So but the bases like copper oxide, copper hydroxide, CuOH twice, ferric hydroxide, FeOH thrice, aluminum hydroxide, AlOH thrice, they do not dissolve in the water. So they are not alkalis. So we call it as the bases. So one of the important one is all alkalis are bases and all bases are not alkalis. So the basis is the main form and the alkalis is the subform of the base. So the one which can able to dissolve in the water, that we call it as a alkalis. The one which do not dissolve in the water, that we call it as a base, which is a common term. Examples here: oxides, sodium monoxide, Na2O. So soluble, when if it is soluble in the water, so we will be getting the sodium hydroxide actually. So insoluble hydroxide is FeOH thrice. So it is insoluble in the water. Calcium oxide, CaO, when it dissolves in the water, we will get calcium hydroxide, that is nothing but a slackered lime. Potassium hydroxide, it is easily soluble in water. And the aluminum hydroxide, which is nothing but the alum, AlOH thrice, it is insoluble in the water. Cupric oxide, CuO, so it forms the CuOH twice, and ZnO. ZnO is actually the amphoteric oxide, so which can easily produce, it can easily reacts with that and forms the ZnOH twice. Calcium hydroxide, ammonium hydroxides, which are all the examples of the soluble hydroxides. So lime water, baking soda and washing soda are all bases. So now we are going to see the preparation of the bases. So so the metal oxides. So the metal oxide means it contains the metal and the oxygen. So we have to precursor as the metal and as well as the oxygen. Suppose if you want to prepare the sodium oxide, so we have to treat the sodium metal with the oxygen. So Na plus O2 gives Na2O. And the potassium oxide K2O. So potassium plus oxygen gives K2O. And calcium oxide, so we have to react to the calcium plus oxygen and it produces the CaO. So these oxides, so okay, how can we prove that these oxides are bases? So whatever the oxide it is produces, that we have to dissolve in the water. So Na2O, when it dissolves in the water and it forms the NaOH. So the hydroxides of the metal. Then K2O, when it dissolves in the water, it forms the KOH. Calcium oxide, when it dissolves in the water, it produces the CaOH twice. So by the action of the water or the steam on some active metals like sodium and the potassium react with the cold water to form the hydroxides with the evolution of the hydrogen gas. So the sodium reacts with the highly reactive metals only we have to take it. Say example, sodium, potassium and all, because it can able to react even with the cold water vigorously. So Na plus 2H2O gives NaOH plus hydrogen gas. The magnesium reacts with the steam. Okay. So the magnesium cannot able to react with the cold water. It can able to react only with the steam. So the steam is nothing but that it is a water vapor, H2O in the form of the gas. So when the magnesium reacts with the steam and it forms the magnesium oxide plus hydrogen. So then the magnesium oxide, when it is actually a insoluble one, so we cannot able to react it with the water. So the Fe reacts with the steam superheated. So when we are more heated, that water, it produces the water vapor. So the iron reacts with the water and it forms the ferric oxide plus hydrogen. Then by heating the carbonates, okay. So whenever we are heating the carbonates, we will be getting the carbon dioxide gas. Along with that, we will be getting the oxides of the metal. So calcium carbonate, this we call it as a thermal decomposition of the carbonates. So calcium carbonate, when we are heated, so the carbon dioxide gas will be coming outside. Along with that, we will be getting the metal oxide, CO. Similarly, when the zinc carbonate, if you are heating, we'll get the zinc oxide, along with that the carbon dioxide gas. So the next one is by the action of an alkali on the salt solution. So for example, when we are uh, when an aqueous solution of the sodium hydroxide is added to the aqueous solution of the magnesium sulfate, so we will be getting the magnesium hydroxide. This is the base plus Na2SO4. The magnesium hydroxide is the insoluble one. So that's why they have shown it in the downward arrow mark. So it is a precipitate. So general properties of the bases. Okay, so what are all the general properties? It's a soapy touch. So when if you are adding the water to the base, so it splits up into the ions and it will give you the OH minus ions. So NaOH when dissolves in the water, so we'll get Na plus OH minus. So the CaOH twice when dissolves in the water we'll get Ca plus 2 OH minus. Magnesium hydroxide when dissolves in the water and it gives Mg plus 2 OH minus. So they always turn the red litmus paper blue. Yeah. So if you want to find out whether it is a base or not, so we have to use the red litmus paper. If it turns blue, then it is a base. So this is just opposite to that of the acid. So for the acids, we have to use the blue litmus that turns the red color. Okay, suppose, okay, so if you want to test whether it contains the base or not, we can take the soap solution because the soap contains the NaOH, so which is a base. So if the soap solution, if you dip the red litmus paper, so it turns the blue color. It indicates that the soap contains the base. Then the bases can able to react with the acids to produces the salt and the water. So neutralization reaction. So NaOH is the base, reacts with the HCl, hydrochloric acid. It forms the salt, NaCl salt plus water molecules. So the KOH, when it reacts with the sulfuric acid, it forms the K2SO4, that is a potassium sulfate plus water. Then copper hydroxide, which reacts with the sulfuric acid and forms the copper sulfate plus water. So in these reactions, what's happening over here is the both acids and bases are neutralizing. So what it means neutralizing? So the H plus from the acid and OH minus from the base both reacts and it forms a water. This we call it as neutralization reactions. So the neutralization reactions may be defined as it's the reaction between the acid and the base which produces the salt and the water. Okay, so now we are going to give an explanation. So here HCl plus NaOH gives NaCl plus water. So when we are dissolving the HCl in the water, so it will split up into the H plus and the Cl minus ion. So the NaOH, when we are dissolving in the water, splits up into the Na plus plus OH minus ion. So the NaCl is the salt, so it splits up into the Na plus plus Cl minus. So the water is a liquid, so it will not dissociate. So we have to keep the H2O as such. So what are all the ions are common? Na plus, Na plus. So we have to cancel out. Cl minus we have to cancel out. So the left out will be the H plus plus OH minus, which produces the water. So during the neutralization of an acid with a base or the vice versa, base with the acid, so basically H plus from the acid and the OH minus from the base, it combines and to produces the water molecules. Then next one is the oxides which produces the acids in the aqueous solutions are called the acidic oxides, which are usually the oxides of the non-metals. Yes. So we have to take the acidic oxide, that is nothing but the CO2. When it reacts with the base NaOH, so it produces the Na2CO3 plus water. Then calcium hydroxide, when it reacts with the CaO, it is a base and this is the acid. So it forms a calcium carbonate plus water. At the same time, so when we are heating the base with the ammonium salt, so it will give you the ammonia. This is the test for the ammonium ions. Suppose if you are testing in the inorganic salts and all, suppose if we may think that the NH4 plus cation is present, so we have to add the little bit of the NaOH and we have to heat it. So immediately the NH3 gas, that is the ammonia gas, will become outside. So how can we confirm that ammonia gas it's only produced in this reaction? Means we have to use the red litmus paper. So it will turn into the blue. So which indicates that the ammonia gas is coming outside. And also it can be able to characterized by its pungent smell. So next one is the bases react with the certain salts to produce as the another salt and the another base. So for example, ammonium hydroxide, when it reacts with the aluminium sulfate, so it produces the aluminium hydroxide and the aluminium sulfate salt. The next one is the strong bases and the weak bases. Again, the same thing as we have seen in the strong acid and the weak acid. So the strong bases are the one when you are dissolving in the water, it will give you the completely ionized. So 100 molecules of the NaOH if you are taking, so it produces the 100 OH minus ions. So that we call it as a strong base. So how much ion OH minus ions it can able to provide. So some bases when it's dissolves in the water completely dissociated. Dissociated means it's completely breaking down and it gives the hydroxide ions. Some of the bases it can able to give the partially dissociated one. So that we call it as a weak bases. So example magnesium hydroxide as well as the ammonium hydroxide. which we call it as a weak bases. They cannot able to they cannot able to give the 100 percentage of the OH minus ion. Instead, it can able to give only dissociate very less. Say for example, 10 percentage or the 20 percentage. Then acidity of a base. Acidity of the base is nothing but the base can how many number of the hydroxyl groups is present in the molecule of the base, that we call it as the acidity of the base. So in the NaOH, KOH and the NH4OH, it contains only one OH group, that is one hydroxyl group. So the acidity of all the bases is 1. But in the case of the calcium hydroxide and the barium hydroxide, there are two hydroxides are present. Two hydroxyl groups are present in the one molecule. So it can able to neutralize the 2H plus. So the acidity is 2. And the acidity of the FeOH3 and the AlOH3 is 3. So because it contains the 3 OH minus ions. So it can able to neutralize the 3H plus. So the base contains one hydroxyl group in a molecule is said to be the monoacidic base. If it contains the 2 hydroxyl group, we call it as a diacidic base. If it contains the 3 hydroxyl group, call it as a triacidic base. So the NaOH, monoacidic, CaOH twice, dibasic, diacidic, FeOH thrice, it's a triacidic basis. Some of the common bases and their uses: sodium hydroxide NaOH. So it is used in the manufacture of the soaps, textile, paper and the medicine. And also it is used in the refining of the petroleum. Ammonium hydroxide. It is a very good reagent in the laboratory and also it is used in making the fertilizers, rayon, plastics and the dyes. So the calcium hydroxide. It is used in making the cement and the mortar and also it is used in making the bleaching powder in whitewashing and it to remove the acidity of the soils. Okay, what is acidity of the soils? How the soil becomes more acidic? So when the acid rain is coming from the atmosphere, it contains basically the HNO3 and as well as the H2SO4. So it will affect the growth of the plants. So to neutralize that, we will use the calcium hydroxide.